Hey there, cool cats and kittens. Welcome back to Mr. Barnes' wonderful, fantastic, super well done, high production value lecture videos for COVID lessons. This one is going to be COVID dose. That's 2 for all you non-Spanish speakers out there. Coming at you loud from my living room. We're going to talk about solving exponential equations with logs, not planning graphic design. As you can see, I've got a lot more experience with one than the other, but let's talk about a couple background information, kind of knowledge, things you need to know about logarithms before we start doing this lesson. So, first thing you need to know is that if we have a log with any base, it doesn't really matter. We're going to ignore the fact that negative bases sort of exist for a while because, you're in high school and we don't want to scare you too much yet. As long as b is any positive number other than 1, you cannot have a negative inside of your logarithm. If the argument of our logarithm is a negative number, then there is no solution. This isn't a 0. This is the symbol for the null set. For those of you who plan on going to college someday and doing math with your lives, that's a fancy thing that means none. There isn't any. No solution. It's not that it's 0. It's that there aren't any. It's empty. So the other background information we need, don't mind my runny nose, that's just the COVID-19 setting in, is log of any base. If the argument is 1, the log equals 0. This is an actual 0 this time. You can tell because there's not a line through it. Let me kind of explain why that happens. So if we have 3 to the power of 0 equals 1, this is just a true equation. We know that. This arrow means I change it into a logarithm using the changey thing. So if we have a base with some exponent equals an answer, we can turn that into a log by doing log of that same base. We put the answer inside the logarithm, and now we call it the argument, and that equals our exponent. So using this definition of a logarithm to rewrite this, we can see 3 to the power of 0 equals 1 turns into log base 3 of 1 equals 0. So the part here that's telling us that this is equal to 0 is because the argument is 1. That's because any base to the power of 0 except 0, or except 0, I don't remember, look that up. 3 to the power of 0 equals 1, 5 to the power of 0 equals 1, a trillion to the power of 0 equals 1. We don't care what the base is, all we care is that the exponent is 0, then it equals 1. Okay, so as long as you know these things here and this rewritey formula right there, you're good to go for this week's homework. So let me do a couple of examples with you guys so that we have a good idea of what we're doing. So example number 1, this one is really straightforward. What you want to do is your very first step for all of these problems. Here, step 1. We want to isolate the exponential. And I'm not going to write out exponential because I can't spell. So the exponential is the base with the exponent on it. That whole thing is considered the exponential. You want to get that isolated by itself on one side of the equation. Once you have it isolated, then what you're going to do is you are going to rewrite this equation as a logarithm. So we're going to put rewrite as a log. Perfect. Okay, so let's go ahead and do that. So our base here is -9. Oh wait, did I do this correctly? This might be a terrible example. C'est la vie. We're not scared. We're going to do it anyway. Log. Our base is -9. Ignore that 2 seconds ago I said we're not going to do negative bases. We'll do it this time. We'll just use our calculator. I'm not scared. Our argument is going to be -33 because that's the answer of this question. -33 equals our exponent, which is k plus 7. So we're going to do k plus 7. Okay, now what we're going to do is we're going to type log base -9 argument -33 into a calculator, and then it's going to spit out a number for us. All right. Anyway, sorry about that, cool cats and kittens. Slight video edit here. I lied. We are cowards. We're going to change these to pluses. These are all pluses now, of course. See, it's just like actually being in my classroom where the examples are made up and the numbers don't matter. So, once we have this thing, type that thing into a calculator, photomath that-ish, type it into Wolfram Alpha, ask your mom, whatever you need to do to figure out what that is. It's a decimal, it's kind of ugly. We're gonna type it in online, and the answer that we get is, we're gonna round it 1.591. Okay, that equals k plus 7, and then to get k, we just subtract 7. So minus 7, minus 7, there we go. K equals negative 5.409. There you go. Wonderful example, well thought out, very well planned ahead. I'm the best teacher ever. You're lucky to have me. You're welcome. COVID-19 ain't nothing. I could do this all day. All right, example number dos. Again, 2 for you non-Spanish people. Cool. So, same thing here. This is just another example. We're going to have to do a little bit of work before we can solve for the exponent this time, though. So here, our exponential is going to be this piece right here. It's the base with the exponent. So we need to isolate this. So we need to get rid of this multiply by 6 first. So the way you undo multiply by 6 is you divide both sides by 6. So 6 and 6 cancel because of math. So we have 10 to the x plus 2 equals 100. Okay. Now, you might be able to tell what x is already because you guys are hard workers, not geniuses. We're not smart. We're just good at working hard. But because we work hard and we're not super smart, we're going to rewrite this as a log instead of just guessing the answer. So when we rewrite this, this is going to be log. Our base here is 10. I'm not going to write the base because if we omit the base and it says log, not ln, the implied base is a 10 anyway. So we're going to be grown-up mathematicians and not write stuff we don't have to. Our argument is going to be the 100. And then that equals our exponent. Wonderful. Now log base 10 of 100. This is asking us 10 to what power gives me 100? Duh, it's 2. So 2, if you don't know that, type it in on your calculator, ask your mom, ask your dog, ask your hamster, Google it, you know, hold a seance, ask a Ouija board, figure it out. Okay, equals x plus 2. Now we need to get x by itself. We're going to subtract 2 on both sides. These cancel, so 0 equals x. So x is 0, that's our answer. Okay, so there's 2 wonderful examples. Number 1, exceptional, some of my better teaching. Number 2, easy peasy lemon squeezy. All right, here we go. Next page. I don't know what that is. Don't worry about that. I did nothing of the sort. Example 3. Okay, now, just one more example to get you guys going and rolling. And then the rest of this, if you missed anything, go back and watch it again. Your homework is posted on Student View. So here we need to isolate our exponential. We're going to divide both sides by -3. So we have 6 to the y plus 5 equals -30. Okay. Now we're going to rewrite this as a log, just like we've been doing. So we're going to have log base 6 of -30 equals y plus 5. Okay, awesome. Now we look, oh look, our argument is negative. Then we think way back to about 9 minutes ago when Mr. Barton told us if the argument of our log is negative, there is no solution. The argument of our log is negative here, so there is no solution. All right, there you go, ladies and gentlemen. Cats and kittens, dogs and dogettes. There is your little review for solving exponential equations. If you guys have questions, email me, Google it, watch Khan Academy, because he literally gets paid to do this. Not that I'm not getting paid, but, you know, figure it out. Ask me on Band, try it, ask your friends, make a group chat, something like that. Have fun being quarantined, stay safe, don't touch anyone, don't go outside. Stay safe, you guys.